In today's note, we're going to look at the Pythagorean Theorem. And what the Pythagorean Theorem is, it is a formula or an equation that's used to solve for missing sides. For missing sides, particularly or specifically, used to solve for missing sides in right, or basically 90-degree triangles. So again, it's a formula that we can use to solve for missing sides in a right triangle. This only works in right triangles, so you do have to look and find this 90-degree angle, or we see that little square in the corner. And that formula is a squared plus b squared equals c squared. And what these variables represent, a and b are the legs of your triangle. And you could say they make the 90-degree angle. So if we look at our triangle, the two legs or the two sides that make the 90-degree angle are this bottom one and this side one. Now it doesn't matter which one you actually label A and B. You could actually label it the other way around, like this, because in our formula, when we're adding them together, it doesn't really matter. Right? Order doesn't really matter when we're adding them. The other value, the C is the hypotenuse. And the hypotenuse is this last side over here, and there's a couple things that we can identify the hypotenuse by. One, it's the longest side. So it's the longest side of our right angle triangle. And two, it's always across from 90 degrees. So if I see my 90-degree angle, that hypotenuse is always going to be the side across from it. So those are the three sides that I'm going to use in Pythagorean Theorem. And what we're going to look at next is a couple examples of being able to find a missing leg or find a missing hypotenuse. So in our first example, we want to solve for the unknown. In this case, we have our two sides and we're looking for this third one. What we want to be able to do is label what our sides are. I do see my 90-degree angle here. So because I know this is my 90-degree angle, the two sides that make up that angle have to be my A and my B value. That leaves the third one as C, and again I could also figure that out because it's across from 90 degrees. Now that I know my three sides, I'm going to use that A squared plus B squared equals C squared Pythagorean theorem and solve for C. So I'm going to plug in the values for A and B. So it doesn't replace the squared, it only replaces the variable, so it only replaces the letter. I'm still squaring those numbers. So 14.2 squared, 201.64 plus 16.8 squared, 282.24, which equals C squared. I can simplify this by adding up those two numbers on the one side. 483.88 equals C squared. Now you may think, okay, I have C on one side, I have a value on the other side, I've solved for my missing side. If you look at the number though that you got, 483.88, if I look back at the triangle in my diagram, if I compare my answer to the other two sides, my answer seems ridiculously large compared to those two other sides. So something right there should tell me that maybe I've done something slightly wrong. Or maybe not slightly wrong, but maybe I'm not done yet. And if we look back at our variable, it's C squared. I don't want C squared, I want C by itself. So what we have to do is we have to cancel out this C squared. And the way we can cancel out that C squared is by doing the opposite. And the opposite of squaring something is square rooting something. So if I square root one side to cancel out the squared, I have to square root the other side. So on the one side, that squared and square root cancel out, which leaves me with c. And then when I square root the other side, I get 21.99, or basically 22 equals c, or 22 centimeters, which is my missing side. And then looking back now at the answers, okay, that is a little bit more reasonable. It's roughly in the same range as my other values. It is larger, which is good because, again, the hypotenuse needs to be the longest side, which in this case it is. And in every case it is, but our answer tells us that as well. Moving on to the next example, this one's a little different because, again, it's oriented a little bit differently. It rotated a little bit differently. So I still want to label my sides. When it's rotated a little bit differently, it helps to find that 90-degree angle first and find your hypotenuse. Once you find your hypotenuse, your other two sides have to be your A and B. And again, the order doesn't matter in that case, so that's why as long as you find the hypotenuse, it's easy to find the other ones. Now that I have my sides, I'm going to plug them in into my formula. So a squared is still unknown. I don't know what a squared or what a is. B I know is 7, so 7 squared equals c squared or 12 squared. I'm going to simplify what I can or get rid of some of my exponents. So 7 squared is 49, 12 squared is 144. Again, remember when you square something, you're multiplying the number by itself. You're not multiplying by 2, you're multiplying it by itself. Now I've simplified it as much as I can, I need to start using some of my algebra. I need to get the a squared by itself, so in order to do that, now what I need to do is move this 49 over to the other side. And in order to do that, I'm going to subtract 49 from the one side, which will cancel things out. I'll be left with a squared, and I do have to subtract it on the other side as well, and I end up with 95. Again, even though I'm solving for a leg, this is not my last step, because if I look at this answer, if I said the leg A was 95, that would make that side larger than my hypotenuse, which I know can't happen. And looking at my two other values, it doesn't really doesn't seem reasonable. It seems too large. So again, the last step that we should be doing is square rooting to cancel out that squared. And in the end, square root of 95, we get 9.75 as our answer. So our missing leg or unknown side is 9.75. And again, this number now does seem reasonable compared to my other values. Our next example, again, we still want to solve for missing sides. So in this case, looking at this triangle, I'm identifying my 90 degrees to find the hypotenuse, because as soon as I find that, the other two sides just fall into place as A and B. So I'm finding these two sides because, again, the next part is to find the area of the triangle. And in order to do that, I need my base and my height. I don't need the hypotenuse, but I can use it to find this missing side length. So I'm going to use Pythagorean Theorem. A squared plus b squared equals c squared. A squared is 37, so 37 squared, plus b squared, which is unknown, plus c squared, which is 62 squared. I'm going to simplify some of my exponents. So 1,369 plus b squared equals 3,844, or 62 squared. I want to get the b squared by itself, so I'm going to move the 1,369 over to the other side and subtract it. B squared equals then 2,475. I need to square root that number to get b by itself. And again, looking at that value of 2,475, I should recognize that's a little bit too large to be a leg. So I'm going to square root that with my algebra. And in the end, we get a length of 49.75 meters, which seems a bit more reasonable for our missing leg. Now, using that to find the area, I have to recall that the area of a triangle is 1/2 times base times height, or base times height divided by 2. I do have my base and my height now, which were my a and b, so I can use my formula. A equals 1/2, not a times b, base times height. So 1/2 times 49.75, which was my base, times 37, which was my height. All one calculation. So 1/2 times 49.75 times 37, 920.38 meters squared is my area. So that is the area of my triangle, and I found the missing side using Pythagorean theorem. The last question, I'll start it off and then we'll pause and let you try this on your own. But a 7-meter ladder is leaning against a wall. If the foot of the ladder is 2.5 meters from the wall, how far up the wall does the ladder reach? So we have our wall here. If we want to kind of draw this out, we know that the base of our ladder is going to be 2.5 meters from the wall. Again, that's one of the key things that it tells us. The foot of the ladder, or the base of the ladder, is 2.5 meters from the wall. So I draw my ladder going up the wall. And it tells us that it's a 7-meter ladder. So then I know that this side is 7 meters long. We could say, we can also, if we want, someone's climbing the ladder. Maybe they're climbing to rescue their cat. Fat cat jumped on top of the wall. So ladder's leaned up against the wall. We want to know how far up the wall does the ladder reach. So I'm looking for this height. We can recognize that the wall and the ground form a 90-degree angle. We're assuming everything is straight and flat, so the wall and the ground form a 90-degree angle. From here, we should be able to identify what our two legs are and what our hypotenuse is, and then plug that into our Pythagorean theorem to find the correct missing side. So I'm going to pause the video here. I suggest you as well, and try this on your own, and we'll come back and share the solutions. So coming back to our example, we should have recognized that across from the 90 degree is our hypotenuse, so that length of the ladder forms our hypotenuse, which means the distance on the ground and the height up the wall represent our two legs. Using that, we plug the A and our B into our formula as well as our C. We don't have an A value, so we have to solve for that missing leg. And again, we're just working through squaring our numbers, moving them over to the other side, subtracting, and then our last step is our square root. And we should get a final length or height up the wall of 6.54 meters. Again, looking at our values, it is lower or less than our hypotenuse, which is good, and it's longer than our base, which again, depending on how you've drawn it, you could argue is correct as well. And it does seem to fall within kind of the range of what we think our numbers should be. Right? It's greater than 2.5 and it is less than 7. So again, we could look at that and say it's reasonable. So again, the main concept from this lesson is looking at Pythagorean theorem and just understanding what A, B, and C represent in terms of a right angle triangle and how to use that theorem to find a missing leg or a missing hypotenuse.